Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the Algebra 1 New York Regents Common Core Examination for January 2015. Number 11 reads, the graph of a linear equation contains the points 3, 11 and negative 2, 1. Which point also lies on the graph? So we have 4 points here. So what do we know about points that lie on a line? So let's say we have a line and we have, let's say, 3 points on the line. Say point 1, point 2, point 3. What do we know about these points? Well, if points are collinear, then the slope using any pair of points is going to be the same. All right, the slope will be constant regardless of any pair of points you select. Okay, so let's write down that remark real quick. If points are collinear or on the same line, the slope, if you calculate the slope using any pair of points, is going to be the same. Okay, so the slope using any pair of points, any pair of points is the same or constant. Okay, so what we're going to do here is, first of all, we're going to find the slope of the line using these 2 points. And then we're going to pick one of these points, preferably the first one, and then we're going to calculate the slope of the line using that point and these 4 options here. Whichever gives us the same answer as the slope using these 2 points, then that point will also lie on the graph. Okay? So let's go ahead and find out the slope of the line first. Slope of the line of the graph that we're taking a look at. Slope of the line. So we are going to be making use of our slope formula. We know what that is. The slope m is equal to rise over run. When you're rising along the y-axis, that's y2 minus y1. And when you're running along the x-axis, it's x2 minus x1. Okay? So we are looking at the points 3, 11, and negative 2, 1. So this will be x1, y1. The first point, x1, y1. The second point, x2, y2. We're using the indexes to identify the positioning of the points. So all we'll do is apply this formula to these points right here to calculate the slope of the graph. So we're going to have the slope m is equal to y2, which is 1, minus y1, 11, divided by x2, negative 2, minus x1, which is 3. All right, let's evaluate this. I'm using the order of operations. 1 minus 11 is subtracting. You keep the sign of the bigger, so it's going to be negative. Negative 10 divided by, you're combining numbers with the same sign, so you add and keep the sign. Negative 5. Minus over minus is plus, slash and dash. 10 over 5 is 2. So your slope is 2. Now, I'm going to take point 1, call this point x1, y1, and I'm going to select, I'm going to test these ones as my x2, okay? Any result that yields 2, that will be the correct answer. All right, so I'm going to go ahead and make a table here to keep my work organized. Let's partition our workspace. So I'm going to have x1, y1 here, and then x2, y2, and then the other a column I'll use to calculate my slope. Okay, so x1, y1 is going to be the original point we had. So 311 will always be our x1, y1. Okay, and now for my x2, y2, I'm going to be altering this. I'm going to be using different options, okay? And then this is my slope m. m is y2 minus y1 over x2 minus x1, the standard slope formula. Okay, so we're going to test different ones to see which one is correct. So now let's pick option number 1. Option 1 is 2, comma 1. Now what are we doing with this point? What we're doing is we are calculating the slope to see if we get 2. If we get 2, that's the answer because they're going to be on the same line. If we do not get 2, then that's not an answer, okay? All right, let's go ahead and calculate it. The slope m is equal to y2 minus y1 divided by x2 minus x1. All right, do the calculations. You have negative 10 over negative 1. Negative 10 over negative 1 is positive 10. 10 is not equal to 2. That means 2, 1 does not fall on the line. That's wrong. All right, now let's move on to the next option. We'll keep x1, y1 fixed because we know that it is on the line. Option 2 is 2, 4. Let's test that point and see if we get a slope of 2, all right? So m is y2, what is y2? 4, minus y1, which is 11, divided by x2, which is, what's x2? 2, minus x1. All right, if we do the calculations here, we will have negative 7 over negative 1, which is equal to positive 7. Is that 2? Nope. So let's cancel that. Option 2 is not on the line. Okay, so let's go to the next option, option number 3. Remember, our goal is to get a result of positive 2. All right, so option 3, we're looking at x1, y1, still the same coordinate, 3, 1. I'm sorry, 3, 11. And then option 3, we have 2, 6. Okay, let's plug it into the slope formula. The slope m, y2 minus y1 divided by x2 minus x1. It looks like our x2 and x1 are always the same. I don't know why that's the case, but we'll just work with that. So x2 is 2 minus x1. 6 minus 11 is negative 5. That's always negative 1. Negative 5 over negative 1 is 5. What does this mean? This means that this point is not on the line because the slope is not 2. So option 3 is wrong. We can see by elimination that our answer should be option 4. Okay, so by confirmation, let's go ahead and plug it in. Now, since option 4 is the correct answer, if I have x1 as 3, x1, y1 as 3, 11, and x2, y2 as 2, 9, since this is the correct answer, what should we get as the slope? Our slope must be 2, okay? So let's hope that is what happens here. y2 minus y1 over x2 minus x1. 9 minus 11 is negative 2. And then 2 minus 3 is negative 1. Minus over minus is plus. 2 over 1 is 2. Excellent. That's exactly what we want. Since the slope is the same as the slope of the line with these 2 points, that means 2, 9, 2, 9 is also on the line that contains these 2 points. So our answer is option number 4. All right, let's take a look at problem number 12. It says, how does the graph of f of x equals 3 times x minus 2 squared plus 1 compared to the graph of g of x equals x squared? So this is a transformation of quadratics problem. So before we go ahead and solve this problem, let's go ahead and go over our formulas for transformation of quadratics. Okay, so let's write that down. Transformation of quadratics. Okay. So let's say we have a quadratic in the form, the vertex form let's see, let's use f of x. In the vertex form, f of x equals a times x minus h square plus k. What does a, h, and k tell us? A tells us something about the width. Okay, so for the width, a, what does it tell us? If the absolute value of a is less than 1, okay, that means that the graph is going to be wider than x squared. If the absolute value of a is greater than 1, then it's going to be narrower. Okay? It's going to be narrower than y equals x squared. And if it's equal to 1, it is going to be the same width. Okay? All right, so that's the information that a tells us. Now, how about h? H tells us about the horizontal translation. Okay, so it tells us basically how the vertex shifts. So let's group them all as the vertices. So when if h is positive, that means you're going to shift to the right. H units to the right. Okay. If h is negative, then you're going to shift to the left. Make sure your formula has to be in this form before all this apply. Uh, K is for your vertical shift. If K is positive, you're going to shift upwards, K units. Okay, and then if K is negative, you are going to shift downwards. Now, if H or K are 0, then you're going to have no shifts in that direction. Okay, so let's keep that in mind. Now we're going to apply this rule to this problem. We have f of x equals 3x minus 2 square plus 1. Okay, so from this problem, we can see what a, h, and k are. So let me write down the formula on the top. F of x equals ax minus h squared plus k. You can clearly see a is 3, h is 2, and k is 1. Okay, so let's extract those values and use our formula here to determine what happens to the graph of x squared when it's translated into this form. Okay, so a is, actually I need the absolute value of a, which is the absolute value of 3. Absolute value of 3 is 3, and that is greater than 1. So what does that mean? If it's greater than 1, that means that it's going to be wider. Okay, f of x is going to be, I'm sorry, narrower. F of x is going to be narrower because it's greater than 1. So f is narrower, narrower than the parent, than g. Okay? And then what else do I need? H. H, what is H? H is 2, and that is what? 2 is positive. Okay? So 2 is positive. Since 2 is positive, what does that mean? That means we're going to shift 2 units in the what direction? 2 units to the right. To the right. 2 units to the right. And then how about K? K is equal to 1, which is also a positive number. So what does that tell us about the vertical shift? You're going to shift 1 unit up, okay? 1 unit up. So what we're looking for is narrower, 2 units to the right, and 1 unit up, okay? Let's look at option 1. Option 1, wider. No, this is not the correct one. Option 2, narrower. Check. Vertex move 2 units right, 2 units. Check. 1 unit up. Check. Excellent. Our answer is option number 2. Okay? So that's that. All right, let's take a look at problem number 13. It reads, Connor wants to attend the town carnival. The price of admission to the carnival is $4.50, and each ride costs an additional 79 cents. If he can spend at most $16 at the carnival, which inequality can be used to solve for the number of rides Connor can go on, and what is the maximum number of rides he can go on? Okay, so first of all, let's write down some formulas. First of all, we want to write down the cost formula. So what we know formula is that the total cost is equal to the unit price times quantity. Okay, so cost is a unit price times quantity. Okay, now in this problem, to calculate the total cost, we have something else to consider. Okay, so total cost is not just the cost of the ticket. You don't just walk into the carnival and pay to get on each ride. You have to pay something first. What is that? The admission fee, okay? So the total cost in this case is going to be equal to the admission fee plus the cost of each ticket, okay? Um, to ride each, the cost to ride each ride, okay? So total cost is admission plus the cost for each for all the rides you ride, okay? So unit price is the price you pay for each ride times the quantity of rides that you go on, okay? Quantity of rides. So you see how we are applying the formula for cost here. This is the cost for all the rides plus the admission fee, which is a flat rate, okay? Okay, so this is what we're going to be using to set up our inequality momentarily. All right, let's go ahead and list everything so we don't make mistakes here. Total cost is how much money Connor has. So total amount he has will be the total cost because he cannot spend more than he has. So total amount, or is going to be the cost, is how much he can spend at most $16. Okay, so that's going to be $16. Admission, how much is admission to get into the carnival? The admission is price of admission, $4.50. Okay, have that down. Unit price, the unit cost for each ride, unit cost or unit price is the same thing. How much does it cost to ride each ride? Each ride costs 79 cents, so it's 79 cents. How do we write that? 0.79. Okay? And then quantity of rides, or let's call it number. Quantity of rides or number of rides. I think number of rides sounds better. Number of rides that Connor can ride. Number of rides. I can call it any variable I want. That's an unknown. But if you look at the options here, what is the variable? They all R's, okay? So let's just use that so it's consistent. Perfect. So that's what we have, okay? Now I'm going to set up my equation, but what I'll do is I'm going to switch it around. I want to deal with the total cost first and then compare it to how much money he can spend. So the admission is $4.50 plus the cost for each ride, which is the unit price, 0.79 times the quantity of rides, R. Now, it is at most $16. What does at most mean? At most means it can't go higher. It could be equal, it can go higher. Can you go lower? Absolutely. So at most means less than or equal to $16. Okay, so let's make this look pretty. We can write this as 4.50 plus 0.79R is less than or equal to 16. So we see that our answers are either option 3 or 4. It cannot be 1 or 2. So what's the right answer here? Well, we have to solve. Okay, we have to solve, or you can plug in and see which one is the correct one. But let's go ahead and solve. Let's not be lazy here. So to solve this, let's go ahead and make use of our algebraic skills. So first thing, we want to get r by itself. Okay, that's the goal here. So you subtract 4.5 from both sides. Subtract 4.5. And then we have 0.79 r as less than or equal to 16 minus 4.5. Let's do that with our calculator. All right, so we have 16 minus 4.5. Answer is 11.5. So 0.79 is less than or equal to 11.5. And to finish this problem off, we'll just simply divide both sides by 0.79. Have the calculator do the work for us. So divided by 0.79 both sides. And then that will give us our value of r. Okay, so let's go ahead and write that down. R is equal to, r is less than or equal to. Let's put that in a calculator. So divide your answer by 0.79, and then you get 14.5. So we have to round it to the round it down. 14.5. You cannot write 0.5 rights. That makes no sense. So the number of rights that he can write is equal to, he can write at most 14 rights based on the amount of money he has. So the answer is option number 3. There goes your final. All right, let's take a look at problem number 14. It says, Karina is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed box plots shown in the diagram below. So she has 4 box plots for her 4 potential destinations. So which one has a high median temperature as possible and a small interquartile range? So before we answer this question, let's go over what the median and the interquartile range are if you're given a graph, okay? Given a box plot. So let's say we have this box plot over here. So what I'm going to do, I'm going to go ahead and indicate where the interquartile range and the median are located, okay? So let's make this green. All right, so right here we have this is the, let's keep messing up, let's fix that. The maximum, let's indicate where the maximum and minimum are. Let's make this green. Okay, so this is your minimum. Let's try that again. This is your min, and then this is your maximum right here. And then this is your first quartile. This is your second quartile or your median, and this is your third quartile. Now, the difference between the first quartile and your third quartile, that is known as the interquartile range. Okay, so this distance from here to here, that is known as your interquartile range right there. Okay, so what I'm going to do, let's go ahead and label all the parts so we can know what we're looking for. So we have here the mean, the minimum. So this is the minimum or lower bound. This is Q1, first quartile. This is the median or Q2. This is Q3, and this is the max. Okay? Now, we're looking for the median as possible. So the line in the box, the one that's farthest to the right, that's the highest median, okay, in these four options that you have right here. And then the interquartile range is the width of the box. How wide is the box? That's the interquartile range, okay? So I'm going to call it IQR for interquartile range. And it's found by computing the difference between the third quartile and the first quartile. Okay, so that's your interquartile range. So the wider the box, you have a greater interquartile range. The narrower the width of this box here, the smaller your interquartile range. In this problem, we're looking for a small interquartile range. So what are we looking for? We're looking for a narrower box. Okay, so first condition though is for the median temperature to be above 80 degrees. So 80 degrees, let's draw that on our graph so we can see exactly what's happening. This is the 80-degree temperature right here, and then the 80-degree temperature right here. So we can see that for ocean beach and serene shores, the median is less than 80 degrees. Let me show you where the median is located. Let's change this. The median is located, I'm going to use the red line. So for Ocean Beach, this is the median right here. Okay? 70 something. And then for Serene Shores, the median is right here. So there you can see that the median of these two locations are less than 80, so they're disqualified. Our candidates for consideration, so let's cross out Ocean Beach and Serene Shores. Whispering Palms and Pelican Beach, those are our two candidates because your median temperature is above 80. Okay? The second condition is smallest interquartile range. So if you look at the width of these two boxes, which one is smaller or narrower? Clearly, Pelican Beach is much narrower than Whispering Palms. So our answer is Pelican Beach because it has a smaller interquartile range. So answer is option number 4. All right, let's take a look at problem number 15. It says some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 5,000 times 0.98 to the x represents the value y of one account that was left inactive for a period of x years. What is the y-intercept of this equation and what does it represent? So we are finding a result and we're also describing what it means in the context of this problem. So how do you find your y-intercept? So to find the y-intercept, where the graph intersects the uh, y-axis, the standard procedure is to set x equal to 0. Okay, so what you're basically doing is evaluating this exponential decay function or depreciation function when x is 0. Okay, so what we're looking for, y-intercept, intercept is simply y evaluated when x is 0. How do you evaluate y when x is 0 here? Simply replace your x with 0 in the function. Bam, like that. Okay? So if we evaluate this, then we know what the y-intercept is. Then we'll talk about the significance after that. So let's go ahead and evaluate this expression when x is 0. So we have 5,000. 0.98 to the 0 power is 1. You remember any number other than 0 raised to the 0 power is 1. So we have 5,000 times 1 is 5,000. Okay, so that's the amount of money when x is equal to 0. So we can eliminate options 1 and 2. Now, what does it mean? What does y sub 0 mean? What does it mean at x equals 0? So just to help you understand what that means, what does y10 mean? When x is equal to 10, what does that mean? X is the number of years that the account was left inactive. So y10 is the means that means that the account was left inactive for 10 years. Okay? How about y of 0? Y of 0 means it was left inactive for 0 years. Okay, so what does 0 indicate? It is the initial amount of money you had before you started to lose, before your money started to lose value. Okay, so let's look at the two options that we have. Y of 0, 5,000, the amount of money in the account initially. Exactly, that's what we want because it starts from 0. There's no such thing as negative years. Okay, you always start from 0, and as your account stays inactive for subsequent years, the amount of money account will start to depreciate using this model that we have right here. This is a depreciation model. So our answer is option number 3. Okay? Thanks so much for taking the time to watch this presentation. Really appreciate it. Would like to know what you think about this presentation. If you liked it or found it helpful, please give us a thumbs up so we'll be encouraged to continue producing subsequent installments of this review series. Don't forget to subscribe to our channel so you get instant updates when we create the next review part of this installment. More clips can be found on mathgotserved.com under test prep. Go ahead and check it out. Thanks again for watching.